Like I said, today we are talking about the Pythagorean theorem, spelled like this. It's probably the most famous theorem in math, and hopefully we remember it being as a squared plus b squared equals c squared. Okay, so Pythagorean theorem, a couple things before we jump into how to use this formula right here, okay? First thing that has to be true is that all the triangles that work for the Pythagorean theorem have to be right triangles. We'll know they're right triangles because the biggest angle, this angle right here, is a right angle noted by this little box, okay? One thing that confuses a lot of people is the way that we draw right triangles. Doesn't matter. They can be oriented in any different way, okay, as long as they have that triangle or that square in the bottom corner on one of the corners. So all three of these guys right here are right triangles. Now, in our formula, in our theorem, we have three letters. We have A, we have B, and we have C. So I'm going to use this triangle right here to illustrate what A, B, and C are. So A and B are each of the legs of the triangle. So I'm going to call them leg 1 and leg 2. Doesn't matter which is which, as long as you know one leg is A, one leg is B. The two legs of the triangle are going to be the two sides of the triangle that make the right angle. So A and B or A and B, doesn't matter, they're interchangeable. C is the only one that really matters, and C is the hypotenuse. Hypotenuse is a fancy word for the side across from the right angle. So C is always, always, always the side across from the right angle. This one cannot be C, this one cannot be C. The only one that can be C is the one that's across from the right angle. So in this triangle right here, we can call this A, this B, but this one is still C because it's the one across from the right angle, the hypotenuse. This one's C right here. Let's call this one B, and we'll call this one A. A and B are interchangeable. The only one that really matters is C. C always has to be across from the right angle. And the reason being, C is the one that's in a different place than A and B. So C has to be different than A and B are. C is always the longest side of the triangle, the right triangle, okay? So let's go into a couple practice problems with how to use the Pythagorean theorem. I'm going to go through a couple where we solve for the hypotenuse, and I'm going to go through a couple where we solve for a leg, okay? So let's start with this first right triangle right here, okay? Let's say that this side is 3 and this side is 4. Let's give it some units because these are measurements, right? So we can actually measure these. So let's make this unit centimeters. Using the Pythagorean theorem, let's solve for the missing side, which I marked with a question mark, okay? So we're missing the hypotenuse. The hypotenuse we can tell because it's across from the right angle. It's the longest side. So let's solve for how long that hypotenuse has to be, okay? So let's call 4A and 3B. You can switch those, like I said, but I'm going to call this one A, this one B. We're going to plug them into our theorem. We get A squared plus B squared, and we don't know C, so we're going to keep C squared as a variable because we don't know what it is, okay? So I see a couple numbers that have exponents, so let's simplify those exponents. 4 squared, if you don't know, open up your calculator. 4 squared means 4 times 4, so that's 16. 3 squared is 3 times 3, which is 9. Okay, now we need to know what C squared is, but we have two numbers added together. These two guys added together are 25. Now, technically, we have what C squared is, but we don't want to know what C squared is. We want to know what C is. So we have to undo squaring C. Now, the opposite of square, does anybody remember what it is? It's going to be square root. So in order to get rid of the square that's attached to C, we have to take the square root of 25. That way we just get C. So when we take the square root of 25, if you're using your phone, I'll show you how to do this, okay? You got to get the sideways calculator up, and you're going to do 25, and then there's a button that says 2 root x right above the sin button, the sign button, and it gives you your answer. So C here is 5. However, we've got some units. Original units are centimeters and centimeters, so final units are centimeters. Any questions on our first example here, guys? With the Pythagorean theorem, you're always going to have to take a square root, so always be ready to do that, okay? All right, let's do another one where we're solving for the hypotenuse, and then we'll do a couple where we're solving for a leg, because that process is a little bit different. Okay, so we have no hypotenuse. We're going to figure out what that is. We're going to solve for that. Let's say we have a 6, 7 something triangle here. 6 and 7. Okay, we'll call this inches, and we'll call this inches. So we've got A. We're going to call A 6. We've got B, which is 7. Plug those two numbers in, and again, we're solving for the hypotenuse. We have to be solving for C. We cannot be solving for A or B because we have the two legs of the triangle. So we've got A squared plus B squared equals C squared. And again, we don't know what C is, so we have to keep it a letter. 6 squared is 6 times 6, that's 36. 7 squared is 7 times 7, that's 49. Okay. Now in our handy dandy calculators, we're going to add these two numbers together. So we've got 36 plus 49, that's 85. And again, we don't have C yet, we have C squared. So our last step with the Pythagorean theorem is always, always, always going to be take the square root. So whatever number we got here, 85, we have to take the square root of it. Remember, that's the 2 root x button right next to the 1 over x and above sign if you're using an iPhone. When we take the square root, we get this gross decimal, but we can round, no big deal. 9.22 is how long C is going to be. Original units are inches, so C has to be inches as well. Okay. Any questions on how to find the length of the hypotenuse of a right triangle using the Pythagorean theorem? All right, spectacular. We're going to do 2 more. We're solving for A and B because it's a slightly different process here. Okay, still using the same formula, but slightly different way of getting to our answer. So we've got a right triangle here. We can tell it's a right triangle because of the square in the corner. Okay, let's say that C here is going to be 10. Let's say that this side's going to be 6, and we need to know what this side is. So this one's different because we have C this time. We have C, we have, let's call this A. Okay, this has to be C because it's across from the right angle. We don't know B this time. Okay, so let's call this feet and feet, and let's figure out how we solve for B. So let's plug in what we know. We've got A squared, we don't know B squared, and we know C is 10. Oops, not C, C. C is 10 squared, okay? 6 squared, 36, easy. 10 squared, 100, easy. Now we gotta get B squared by itself before we take the square root. We can't take the square root like it is right now. We gotta get B squared by itself. So we're gonna subtract A squared away. Since it's added, we subtract it over. It's kind of like when we were solving equations a couple of units ago, okay? So we move the 36 away. We're left with B squared, and 100 minus 36 in your calculator is 64. Now this looks like the other two problems. We have a letter squared equal to a number. So how do we undo a square? We're going to square root it. So in our calculator, we're going to do 64, take the square root to get B equals 8. Now our original units were feet, so our final units have to be feet as well. Okay, so one extra step here. We have to move the number away from the letter that we don't know. Otherwise, same exact process. Plug in what we know, and at the end, take a square root. Square root's always going to be our last step here. Okay? All right, we're going to do one more together, and then I'll let you guys fly and practice this on your own. All right, so let's have a right triangle that looks like this. We can tell it's right because of the square in the corner. Let's make our hypotenuse 7 here, okay? Let's make this side 4, and we don't know this side. So 7, we'll do 7 miles, 4 miles, and we don't know this. So let's call this A. Let's call this C. We have to call it C because it's the hypotenuse, okay? So we plug in what we know. 4 squared, we don't know B, C squared. I don't know why I keep doing that. 4 squared, 16. 7 squared is 49. If you forget how to get these numbers, it's just 7 times 7, 4 times 4. This is another one where we've got that extra step because the number is by the letter that we don't know. So we got to move 16 by subtraction. Okay, we're left with b squared. 49 minus 16 is 33 when you type it in your calculator. And now we're at our last step where we take the square root. That way we just get b. So in our handy dandy calculator, 33 is not a perfect square, so we're going to get a decimal. 33, take the square root, we get 5.74 when we round, okay? Original units were miles, final units have to be miles.